Okay, so my name's Alasdair Allan. I'm an editor for Make magazine, and this is an introduction to choosing the correct microcontroller board for your project. Currently, we're seeing an explosion of new boards coming into the market. And there doesn't seem to be any reason to expect over the next year or two we're going to see any sort of slowdown on that trend. If anything, we're going to see more boards, not less. Although a few of these boards are actually going to disappear just as soon as they arrive. And it's actually really hard to differentiate between these boards, not just for the beginner, but also for the advanced user. Because a lot of cases, the difference between these boards don't really matter that much. And as recently as 6 months ago, the choice is actually going to be fairly simple. If you wanted to talk to arbitrary bits of electronics, your best bet was to buy an Arduino microcontroller. And if you needed the power of an ARM-based board and you wanted to run Linux, you should probably buy a Raspberry Pi. That is if you could get your hands on one. There were actually about 6 months waiting list for one at that point in time. That's all cleared up these days, but about 6 months, a year ago, it was really hard to get your hands on one. I'm going to talk about some alternatives, but if you just wander off now, that's actually still pretty good advice because of the large communities that are built up around them. And I know Jason, who's works at a Beaglebone, which I will mention in a couple of slides, Jason, don't worry, is frowning at that. But it is still good advice because one of the thing here is that if you have problems, what do you want as a community to be able to solve those problems ahead of time? If you want to be able to go to Google and type your problem in, and then someone's already solved it, because you just want to make your thing. You don't want to have to solve problems with the board, right? Anyway, let's talk about microcontroller boards and the Arduino. Now, every so often, there's a piece of technology that can become a lever that lets people move the world. And just a little bit. And I think the Arduino is one of these levers. It started off as a project to get artists access to microcontrollers for interactive designs, for installations and embedded, so they could do embedded processing. But I think it's going to end up in most of the science museums around the world as one of the building blocks of the next industrial revolution. It allows rapid, cheap prototyping for embedded projects, and it turns what used to be fairly hard hardware problems into software problems. And we know from the Valley what happens when you turn things into software problems. They just become easier. It's based around an 8-bit Atmel AT-Mega processor, and like all the development boards I'm going to talk about, it breaks out the digital, analog, PWM, and other pins to easily accessible sort of headers down each side of the board that you can plug wires into and breadboard things with. It's got a somewhat idiosyncratic footprint, but that's actually one of its advantages is because it's becoming a standard. Just by sheer force of numbers, the community around the Arduino board is turning the footprint of the board into a hardware standard. It's a solid development platform, both for beginners and experienced users. Although strangely enough, the real power of the Arduino system isn't the hardware at all, it's the software, it's the Arduino development environment. And while there are many other boards out there offering similar functionality, the Arduino has perhaps succeeded the best in wrapping the hard bits of developing for a microcontroller board down into software and hiding the hard bits away from the user. And because of that, it's spawned many imitators and clones, and it's built that community I was talking about that's so important. There are alternatives, of course. While the Arduino is based around the Atmel AT-Mega, this is the Texas Instruments Launchpad based around their MSP430 processor. Now, the MSP430 is actually a pretty similar chip to the Atmel AT-Mega, which is used by the Arduino. But there are some differences. One of the differences is that this is a really low power chip, and it's also got really good sleep functionality. So if you want to use a project where you want to use really low power, or you're going to stick it in a battery and stick it somewhere fairly inaccessible, and you want to run for a couple of months before you have to go down there and change the battery, this is actually a really good alternative. The big problem, at least until recently, is developing for the MSP430 and the Launchpad was actually pretty difficult. It used to use the Eclipse environment, so if you weren't a professional software developer, if you weren't used to using those big enterprise-level tools, it was actually pretty hard to develop for this board. This has all gone away. This is the Energia environment, which, if you looked at the previous slide, looks exactly like the Arduino IDE, except this one's red, which is obviously a major difference. It's red. The code inside it is pretty similar to the Arduino code you're going to use. But it's pretty much solved the development problem for the Launchpad. Energy is still in active development, so there's some things that you can't get access to on the board that you could do if you use Eclipse, but that's going away. So it's becoming easier to use the MSP430, which is a really cool chip, as a good alternative to the Arduino. So, single board computers. So single board computers existed well before the arrival of the Raspberry Pi. I was using a board called a gum stick, so-called because it was the size of a stick of gum about 10 years ago in a few projects. And they'll exist long after the demise of the Raspberry Pi. I mean, but like the Raspberry Pi, like the Arduino before it, the Raspberry Pi has basically single-handedly rebooted the market for single board computers. And like the Arduino, it's brought an explosion of boards to the market. Not clones, not competitors really, but it's a sudden awakening of realization that there's a market for these boards, that people want to use these boards, that they're actually useful. Unlike the Arduino, the Raspberry Pi wasn't designed for makers. It wasn't designed for us. It was designed for educators. And it's actually quite hard to talk to hardware from it. It has very few capabilities to talk to hardware. We use it all the time as makers, but that's because it costs 35 bucks. It was cheap enough that we could overlook the downsides of the platform to see the fact it was cheap, and it had the power that we needed, and it had some of the power to talk to hardware capabilities. And a lot of people have worked around it, and there's some really cool hacks and cool projects that have been done with the Pi. The Pi is a large step up from the Arduino in terms of processing power. It was designed to run Linux. It's got along the same interfaces as your laptop or your desktop. It's got HDMI, Ethernet, USB. So programming the Pi is pretty much like programming a computer. You can use Python, Ruby, Perl, JavaScript, Fortran, whatever you actually want to do to write code for this platform. It's just a computer on a board. The clue's in the name there. But as I said, it doesn't have a lot of general purpose I/O pins. You can see the small bank labeled GPIO there. That's what it has. So it could be an issue if you use lots of pins. This is the Beaglebone Black from Texas Instruments. It was unlike the Pi, it was designed from the ground up to talk to arbitrary bits of hardware. Sensors, actuators, other things. It was designed for makers rather than educators, and it really does show. The original Beaglebone was just a little bit too expensive, however. At 89 bucks, it didn't really manage to build, and Jason, you'd happy what I'm saying there, right? Yeah. It didn't really build the momentum that the Pi did, just because it was far more accessible for the general user, because the Pi was 35 bucks. But this is the latest board from Beaglebone, which is the Beaglebone Black. Again, the clue's in the name. This one's black. The previous one was white. Beside this new color, the new board it has the same footprint. It's got a similar layout. But crucially, the price has dropped from 89 bucks to 45 bucks, which is a much more competitive price point. But it's also a big step up from the Raspberry Pi, so you get a whole bunch more for that extra 10 bucks. It's a faster processor, it's got built-in file storage as well as the SD cards. And it's also got the same Ethernet, USB, and HDMI, and the Pi has. But crucially, it's got a lot more general purpose I/O pins. You can see the headers here. There's a lot more headers here than there was in the Pi. So just to quickly summarize, there was the Arduino, 25, 30 bucks. The TI Launchpad, just 10 bucks. It's got a few less pins than the Arduino. Energia isn't quite fully baked yet, but it's a really solid alternative. Single board computers, there's the Pi at 25 to 35 bucks. The 25 buck one doesn't have any Ethernet, the 35 buck one does, but it only has a few digital pins. And then there's the Beaglebone Black, a little bit more than the Raspberry Pi, but it has a lot more ability to talk to hardware. And if you want to talk about the Beaglebone Black, like, get Jason, stick your hand up. Talk to Jason at the end of the talk. That isn't the end of the story, however. There's also a few more boards you should probably know about. There's the Arduino Un, and this was announced earlier in the year at Maker Faire. This is the first of the Linux boards to come out from the Arduino company, and it comes with integrated Wi-Fi. But the interesting thing is it's fundamentally two different boards. It's got a Arduino Leonardo on one hand, and then a separate Linux MIPS processor on the other hand. And then there's a special bridge library that lets the Arduino side talk to the Linux side, and the Linux side talk to the Arduino side. So you can do all the networking and heavy lifting of XML and JSON processing on the Linux side via RESTful API, mostly, if you want to. And the talking to hardware bit on the Arduino side, as well as using all the Arduino shields. You can program it remotely via Wi-Fi, as well as the usual USB cable. And Arduino have partnered with a company called Tembu to give one-stop API access to data from Twitter, Facebook, Foursquare, FedEx, PayPal, and a few other companies. So you can really get good, easy access to social data. Downside is it's 69 bucks. Which, you know, is pretty expensive, but you do get two boards in one, so maybe that's acceptable. If you actually want to get one, the Maker Shed still has a few on the shelves, I think, and this today, like, the Maker Faire was the first time you could get it inside the US. One more board I do want to mention is the Tessel. This is a board that's not actually in full production yet, still in a crowdfunding campaign. It's one of the first products to come out of Dragon Innovation. Dragon have a stall over there. The Limber board, if you were the previous talk, that's another one of the Dragon Innovation crowdfunding campaigns. Now this Tessel board is actually a board built for web developers, not hardware hackers. It runs a JavaScript interpreter based around the Lua runtime, and it's compatible with Node.js. So if there's any web developers in the audience, that meant a lot to them. Anyone else, didn't mean anything at all. Basically, it lets you run JavaScript and an event loop directly, well, not directly, but as close to the bare metal as you possibly can get, which is an interesting concept. It comes with built-in Wi-Fi off the shelf, so it's effectively a board that's designed from the ground up to be part of the Internet of Things, which is like a really cool concept, and I'd be interested to see if it brings the JavaScript community with it, because I think that's really important for the microcontroller boards is the communities. And the Node.js community already has some history of hardware hacking. There's Nodecopter and a couple other things they've been doing which are really quite interesting. So it's going to bring in a lot of new makers if it does bring the whole web development community with it. So that's pretty much what I've got. So any questions, or we can close out? Nope. Thank you very much.